Hello, everyone. My name is Steve Adolf, and welcome back to Conversations with AI. In this episode, we'll explain why AI isn't just a productivity story. And this episode really follows up from the previous episode. I could guess you could call it now that one episode 0, where we talked about the Lineshaft and how switching to electric motors as a drop-in replacement in factories did lower the price of powering the factory, but really didn't have a substantial transformative effect on the factory output. So electricity really didn't start becoming transformative until we actually changed the layout of the factory. And this is a very similar metaphor that we can start to apply to the adoption of AI. It's simply not, the best outcomes are not simply going to be using AI as a drop-in replacement in our workflows. So just quickly, the whole presentation here, the bottom line up front really is, in conditions of uncertainty, we will win with AI when we use it to accelerate our learning. And I'm going to define learning as reducing uncertainty about value, feasibility, and risk. Okay, so the dominant approach to AI is actually using it to optimize steps in our workflow. Often you hear about how AI could quickly summarize calls, how AI could be used as replacements in call service centers, how AI can be used to enhance coding. So this is kind of very much the drop-in replacement. This is the modern equivalent of our Lineshaft metaphor. However, unlike simply dropping in the electric motor to replace the steam engine, which did create some savings, dropping AI as a replacement for a manual step in a process has the real risk of creating a productivity trap. This can result where we optimize local work like coding or reporting, but without removing the real constraint in our value stream or work process. So what ends up happening is we end up really creating more work in progress and extending the queues and delaying evidence of learning and therefore actually worsening our outcomes. Right? This is straight out of Goldratt and theories of constraints. If you speed up a non-bottleneck step in a process, then you're going to grow the queues and you're going to delay feedback, which in a rapidly changing world is the opposite of what we want to achieve. And a common example is we talk a lot about AI augmented coding. And so here we've got sort of a humorous diagram where an AI is quickly creating pull requests, and yet here the review step is the actual bottleneck. So now we have this queue, the work in progress for the reviews is growing, it's increasing the leading time, it's delaying learning. So what we're arguing here is that what's going to free us of the Lineshaft constraint is we want, and what's going to give us those transformative benefits is going to be, can we use AI to accelerate learning? And the fundamental assumption we're making here is that we are in a rapidly changing world, that in fact change is happening faster than our traditional systems and ways of working can cope with. And this is a quote again from Eric Ries: the only way to win is to learn faster than anyone else. And this is where AI is really going to step in to help us. And again, what do we mean by learning, right? It's reducing uncertainty fast enough to change a decision. And this is just something we've known for a long time, these learning cycles. Here we have the classic example of the PDCA loop, the plan, do, check, act loop, right? We plan, we have a hypothesis. If we do something, we will learn this, we will get these benefits, and this is how we will know. Do, we execute. The check, we test our hypothesis against the data we learned, and the act is the adjustment. We act on our learning. Stop doing what we were doing. pivot, change what we're doing, or continue on. And most important here is doing it with credible evidence, right? What are the real data, not vanity metrics that we can measure, but real outcomes that we can measure to help us quickly learn? And again, emphasizing learning faster than the rate of change. Learning lag, right? Increasing the delay, increasing work in progress, increasing the cues which delay learning could turn good execution into wasted investment. This little humorous cartoon I had Nano Banana create was showing we see these eager engineers who are showing how well they've executed, and the leadership is going, well, that solved last year's problem. But to take away the humor, it really does not take much imagination to imagine what happens to an enterprise when your learning speed falls behind the rate of change. And so this is more than just some abstract organizational theory. In a rapidly changing world, this will cost you real money. Slow learning has deep financial consequences. This was something that McKinsey stated a while back in a paper. Budgets exist to enable strategy. And there may be a big, well, duh moment with this, but consider this. In a rapidly changing world, is the business case you used to launch a project still valid? Right? And we need to ask that question, because it really is, the implications of that are, is our spend still aligned to strategy? How quickly can we detect that that is no longer the case? And then also the question is, how quickly can we stop or pivot? And this is a real concern, because according to Accenture and a number of other consultants, the hybrid framework of waterfall and agile is becoming the dominant framework in product development. So we get a lot of learning cycles during execution and delivery, but how many learning cycles do we have with understanding, are we building the right thing? In this diagram here, you can see there's multiple learning cycles. We have multiple technical learning cycles. We're learning that if we're building things right. But the real question is, the real economic question is, are we building the right thing? And if you can see, like, for example, in a hybrid model, we get one learning cycle when we deliver. And we have a extremely long delay between concept and cash. So going back to the real economic benefits of electricity, when we say AI is the new electricity, what we're really referring to is how electricity removed the constraints of the Lineshaft and allowed us to reorganize our way of working. AI, the modern equivalent, is to use AI to remove the learning constraints in our processes, to be able to accelerate our ability to learn. So how will that happen? Hello, ChatGPT. You and I have been working on this presentation together, and I've presented an argument that the transformative power of AI is not simply productivity enhancements, but just as electricity liberated the factory from the workflow constraints of the Lineshaft, AI's superpower is augmenting cognitive work by making what would otherwise be tricky and weak data signals visible. What are 5 ways that AI can help free us from the constraints that impede learning?
Certainly. Let's lay this out clearly. In a more clinical sense, AI can remove learning constraints by doing the following. Surfacing subtle patterns. AI can detect weak signals in large data sets that humans would miss, effectively freeing us from the constraint of limited human perception. Automating data integration. By aggregating and correlating information from multiple sources automatically, AI reduces the friction of manual data gathering, allowing learning processes to proceed without waiting for human-driven data collection. Providing real-time feedback loops. AI systems can offer immediate insights and recommendations, shortening the time between action and learning and thus removing delays that traditionally slow down learning cycles. Simulating scenarios. AI can create simulations and predictive models, allowing us to test hypotheses and learn from virtual experiments without the constraints of physical trial and error. Personalizing learning pathways. By tailoring information and learning journeys to individual needs, AI can remove the one-size-fits-all constraint and enable more efficient knowledge acquisition. In summary, these are ways in which AI effectively lifts constraints that impede learning, much like electricity freed factories from Lineshaft constraints.
So, if I were to ask you, in a typical enterprise, what are the top 3 learning constraints that slow down decisions? Now, keep it practical and include what must be validated by humans.
Certainly. In a more straightforward and practical sense, 3 major learning constraints that typically slow down decision making in an enterprise are as follows: data validity and quality. One key constraint is that humans often have to spend time verifying whether data is accurate and relevant before making decisions. AI can assist, but human validation is often still needed to confirm that the insights are based on trustworthy information. Contextual interpretation. Another constraint is that humans need to interpret data in context, understanding nuances and the bigger picture of the business environment. While AI can highlight patterns, humans still have to validate that these patterns make sense in the real world scenario. Decision accountability. Finally, there's the constraint of accountability. Even if AI provides recommendations, humans need to validate and take responsibility for the decisions, ensuring they align with organizational goals and ethics. In short, these are practical constraints where human validation is typically required to ensure sound decision making.
So, is there any last guidance that you would want to, or a summary that you would want to give our audience here about the adoption of AI?
Certainly. In summary, the key takeaway is that adopting AI isn't just about boosting productivity. It's about rethinking workflows and removing old constraints, much like how electricity transformed factories. Make sure you validate AI's insights carefully, integrate human judgment where needed, and remember that the real power of AI is in enabling new ways of working, rather than just optimizing the old ones.
So, just like electricity was in the late 1800s, AI is a new technology. And like electricity, when we dropped the electric motor in as a replacement for the steam engine, some benefits will flow because it will make existing processes more efficient. But just like the factories, the real transformative benefits will come when we use AI to transform our way of working. In this case, to learn faster. And to help maybe you think about this point, here's a simple exercise you might try at home. Just to ask yourself, what would happen if we could remove the learning constraints on a process? So look at this here. Like, first of all, identify that process. We could talk about maybe the product development life cycle that I introduced, right? We talked about the hybrid life cycle. And what is the decision we need to make? Well, we could need to ask the question, will this product deliver value? What's the evidence of that supports that decision or enable that decision? Well, typically in most hybrid product development life cycles, it's the forecast that's in our business case. What is the learning What's the learning bottleneck? It's the validation of that business case. When do we get the data, the demand signals? Well, in our traditional hybrid processes or waterfall processes, those demand signals arrive late, usually after release. So, our hypothesis here is if we could reduce the time to evidence, in other words, if we could get the demand signals much earlier and have more learning cycles in the product development life cycle, what would be the impact for us? Could we, for example, be able to remove projects earlier that will fail to deliver on their business case? What would be the benefits? Don't have to worry about how we will do that. Just look at for now, what's the learning bottleneck? If we could learn earlier, what would be the economic benefit of that? You will find a canvas with this video here in the YouTube video. So, thank you for joining me with Conversations for AI, Episode 1. If you enjoy these, please, of course, give me a like and subscribe to my channel. And in the next episode, we're going to talk about the transaction cost of learning and how AI doesn't replace thinking. It changes the cost of learning and therefore enabling more learning cycles. Again, my name is Steve Adolf, and thank you for joining me.